Hello, in today's session we will continue our discussion about hyperbolic functions, and mainly we will tackle the derivatives of such functions. So we defined that the sine hyperbolic function is exponential ax minus e power minus x over 2, while the cosh x or cosine hyperbolic of x is ex plus e power minus x over 2. And those are the drawings of the two main hyperbolic functions. Now, if we want to perform the derivative of hyperbolic functions, we are given the following table at which we can use. But we should be able to derive the equations as well. So if I want to prove like the derivative of sine hyperbolic of u is equal to cosine hyperbolic of u, and this is of course the chain rule, the derivative of the function it holds. Let's say that we want to find the derivative of sine hyperbolic sinh of x, okay, d by dx, right? So this would be equal to the derivative of ex minus e power minus x over 2. This constant can be moved outside the derivative, so we end up with ex minus e power minus x derivative. D by dx is denoted by prime. The derivative of ex is ex, and the derivative of e power minus x is minus e minus x, okay, which is equal to ex plus e power minus x, and this is equal to cosh of x. Alright, so the derivative of hyperbolic, sine hyperbolic, is the cosh. Of course, we have the chain rule, du by dx, in case this u is some function of x. Alright, let's derive the tangent hyperbolic, the derivative. So the derivative of tangent hyperbolic of x, the tangent is sinh over cosh, okay, and we know that if we have two functions, u over v prime, it is u prime v minus v prime u over v square. So this would, the derivative of sinh is cosh, and multiplied by cosh, minus the derivative of cosh is sinh, multiplied by sinh, over cosh square. This equal to cosh squared, cosh square minus sinh square over cosh square. And on a previous session we proved that the hyperbolic cosine of x minus the sine hyperbolic sine of x is 1. This is equal to 1, and you should be able to prove it. Okay, so this is cosine hyperbolic of x, which is equal 1 over cosine, it is secant hyperbolic of x square. Okay, so this is secant hyperbolic, and of course we shouldn't forget about that chain rule. And you should be able to derive the rest of the equations. Now let's do some practice. If we are given a function, or we are asked to find the derivative as a function of t of tangent hyperbolic radical 1 plus t square. Okay, so the derivative of tangent hyperbolic is secant hyperbolic square, right? We proved that. So it is secant hyperbolic. So this is u. I mean, this is u. This is u. Okay, so it is secant hyperbolic square of radical 1 plus t square multiplied by the derivative of the function it holds. Chain rule, remember that. D by dt of radical 1 plus t square of u. Okay, so the derivative of radical 1 plus t square is the same as the derivative of 1 plus t square power half. So in the derivative we take it would be half 1 plus t square, half minus 1, which is minus half, multiplied as well by the function it holds. Chain rule. Okay, the derivative of 1 plus t square. So this is equal to 2t. Derivative of 1 is 0 and t squared is 2t. Okay, and this is equal, we can bring it down and it becomes power half, which is radical 1 plus t square multiplied by 2t. So the derivative of radical 1 plus t square is t over radical 1 plus t square secant hyperbolic square of 1 plus t square. Okay, let's take another function or another example. Okay, if we are asked to find the derivative of cosine hyperbolic 3 of x over x square. Okay, remember the derivative of two functions, u over v, again it is u prime v minus v prime u over v square. So what is the derivative of cosine hyperbolic 3x? Okay, so the derivative of cosine hyperbolic 3x is sine hyperbolic of 3x multiplied by the derivative of 3x, which is 3 sine hyperbolic 3x. So this becomes the derivative of cosine by x squared, which is 3x squared sine hyperbolic. Okay, so the derivative of this multiplied by the x squared minus the derivative of x squared is 2x multiplied by cosine hyperbolic 3x over x power 4. So square to the x squared is x power 4. So now we can take off 1x. We end up with 3x sine hyperbolic 3x minus 2 cosh 3 of x power 3. Let's take another example. Now you are asked to find the derivative of gosh 2x squared minus 1, all of it power 2. We know that if we have x power n, the derivative of that is n xn minus 1 multiplied by the chain rule x prime, which is 1. So the same thing applies here. Okay, so we take the power down, 2 gosh 2x squared minus 1. We subtract from the 2 1, it becomes 1, multiplied by the inner function, which is d by dx gosh 2x squared minus 1. Okay, so we need to determine the derivative of gosh. Okay, so the derivative of Gauche 2x squared minus 1 is sinh. Okay, this is u, huh? Okay, this is u. So Gauche of u is sinh of u, du by dx, the derivative of 2x squared minus 1. The derivative of 2x squared is 4x, and minus 1 becomes 0. Okay, so we just substitute this. Okay, 4x multiplied by 2 is 8. X Gauche 2x squared minus 1 multiplied by sinh 2x squared minus 1, and that's it. Let's take a final example. If we are asked to find the derivative with respect to dt as a function of t, the cotangent hyperbolic of Gauche to t. Okay, so the derivative of cotangent hyperbolic is minus cosecant hyperbolic of the function it holds, right? Of u. This is u. Or this is u. Okay. Gauche to t. Okay. Multiplied by du by dx. Du by dx. Okay, which is the derivative with respect to the variable t. Gauche to t. The derivative of Gauche to t is sinh to t multiplied by the function it holds, chain rule, which is 2. Okay, this yields 2 cosecant hyperbolic Gauche to t. Okay, sinh to t. Alright. I hope now you take a general overview how to perform the derivatives of such hyperbolic functions, and the table in front of you, you can use it, and you should be able to derive those equations as we did at the beginning. So we come to an end for the derivatives of hyperbolic functions. Remember always the chain rule at which you need to derive to perform the derivative of the function it holds. Thank you.